Yeah, you can export to any other file type, almost any file type. And of the 3D, 3D Studio, AutoCAD, the generic ones, the STLs, those are the 3D printer files, the OBJs, the object files.
The industrial design class that I
Uh-huh.
have with Mr. Smith.
Yeah.
We have a Student Fusion 360. I haven't played in it yet.
I don't know it off the top of my head, but we'll see. Usually Rhino talks to everything, or at least can go into an intermediary format that can then go through. But I'll investigate it a little bit more. I'm not familiar with it, so yeah. Okay, so we're going to get started with exercise 203. We'll do a little bit more two-dimensional drawing, and then we'll give you your first introduction to 3D work in Rhino. And so I know it's slow in the beginning, but we got to get everybody on an even playing field. And once we all get on that even playing field, then we'll start to pick up speed. I believe that V-Ray should be fixed by Wednesday, fingers crossed, because that will be our first day really working in V-Ray. So I try to weave in V-Ray as we go along. So we'll do mostly Rhino in the beginning with a few days of V-Ray scattered in just so you get some practice. The goal is that when you are eventually going toward your first assignment, your chair and table, you'll have enough V-Ray to do some basic rendering as part of it. So that's why I weave it in as we go along, though we'll spend most of our time in Rhino in the beginning. As we move toward the end of the class, the two will flip-flop, and we'll spend more time in V-Ray and less time actually instructing in Rhino. It doesn't mean you'll stop working in Rhino. Obviously, we'll be working in Rhino heavily, but I'll spend more time instructing in V-Ray. So anyway, right now we're going to continue in our basic drawing in Rhino. And I was one step ahead of myself here. Okay, so I'm going to go back, and I was showing this in perspective as we got started, but I'm going to go ahead and get myself back into the basic top view. And this is a little bit further along than I got when I was demonstrating it live last class, but this is kind of approximately where I hope you got as part of your last exercise. So for today, for exercise 203, I want you to go ahead and start working with your exercise 202 file that you did last time. The door swings and the doors themselves are not really critical at this point, nor are really the windows. We're going to use them as kind of cues as part of this drawing that we're doing today, but you can make some modifications as we go along. So before we get too in-depth in today's drawing, I want to take a little bit of time and sort out our basic layer structure. And I haven't talked about layers just yet in Rhino, but as you start to move forward and create more and more complicated drawings, layers become really critical in Rhino. And I would argue that layers are even more critical in Rhino than they are in AutoCAD or in Illustrator or in anything else that you're doing. Because as we get more and more complicated 3D models, we can have hundreds or thousands of layers. If you think about, let's say I'm doing a house, okay, and I may have layers for a bunch of the house geometry itself, but then I may bring in an object, a furniture, a couch, a table, a chair, and that object might have 10 different layers associated with just that object. And then I bring in, 6 different couches, and suddenly you can see how this multiplies out in a hurry, and I start to have lots and lots of layers. So let me go ahead and delete these layers. We don't need them for right now. Yes to all. I can create anything new. So chances are in your drawings thus far, you've worked in your default layer. If you're not seeing your layers over on the right side here, across the top in the standard ribbon, there's a little pie-shaped piece. It's a red, white, and blue pie. If you click on that, it will bring up the layers palette on your right side of your screen. And chances are you did your drawing on the default layer. That would be my guess. Usually that's the default. It's the equivalent of layer 0 in AutoCAD. So it's your kind of your base layer. Now, as we move forward, we're going to want to create layers. And if we look at this layers palette at the top, the first button here is New Layer. And so if I click on that, it will create a new layer. By default, the new layer is just numbered, layer 01. If I were to create another one, it would be layer 02. Naming your layers really helps, because if you leave them as layer 1, layer 2, layer 3, and you have 1,000 layers, before you know it, you're not going to, if you had 50 layers, you wouldn't remember what was on what layer. So you really want to start thinking about how you organize your layers very early in the process. So I'm going to go ahead and call this layer 2D drawing. And so I'll type out 2D drawing, and I will click off, and it will stay as 2D drawing. Okay? Now, one of the best things about Rhino and its layer structure is Rhino allows for you to nest layers. So one layer can be a sublayer of another layer. And this is very different than AutoCAD. AutoCAD groups layers, so you can have layer groups, but you can't have actual sublayers. And Rhino works with sublayers. So with 2D drawing as my layer, I've selected it so it's blue in color. Immediately next to new layer is a button for new sublayer. And so I'll go ahead and click on new sublayer, and I'm going to have a new sublayer called walls. Okay? So now I have a 2D drawing layer, I have a walls layer. Right? And while we're here, let me create another new sublayer, and we'll call this elevation. Okay, so I have a 2D drawing layer, I have a walls layer, and an elevation layer. Okay, so that's starting to work out rather nicely. If I want to change my objects to a specific layer, I can select my objects and then come over to the layer menu. If I right-click, obviously I want these to go on the walls layer, so I can right-click on walls, and I can come down here to change object layer. And now those objects are part of the walls layer. The current layer that you're drawing on contains a check mark next to it. So my default layer was my current layer. That was what I was drawing on. My walls layer here is not my current layer, but it is on. So there's a light bulb that represents on. There's a lock, a little padlock that represents locking the layer or unlocking the layer. For right now, we're going to leave it unlocked. And there is a color for the layer. The color has nothing to do with rendering. It just has to do with how you view the layer itself. So for example, I could take my color, I could turn it red, and objects that are on the walls layer would turn red. So obviously all my objects are currently red. So I want to take a little bit of time and I want to draw out an elevation, or at least the start of an elevation for this particular building. And I'll draw the south elevation down here for ease. And so because I want it to be on the elevation layer, I'll go ahead and double click on elevation, and you see that the check mark moves to the elevation layer. Okay? I can also change the color to be a different color so that I can see it. One side note, when you're picking colors for layers, don't ever pick yellow. It actually shouldn't be an option for you to pick, because if you were to pick yellow, it's exactly the same as if the object is selected and you can't tell the difference, and it will drive you nuts. Okay? So don't ever pick yellow. Any other color is fine. So I'm going to go ahead and pick blue just so you can see it for right now. The truth is, when I'm modeling, I almost always just model in black. It really doesn't make much of a difference. So with the elevation layer as the current layer, it has the check mark, I'm going to go ahead and draw out the beginnings of an elevation. And so we'll start with just the Polyline tool, and I'll pull a few lines down as guides. So we'll pull a line down there. I'll right-click to repeat the command. I'll pull a line down here. I'll right-click to repeat the command, and I'll pull a line down here. So it's kind of like in AutoCAD, we were, if you were in my 135, we did those rays and pulled them down in AutoCAD. We're essentially doing the same thing. I'll go ahead and give myself a ground line. So once again, I'll pick the polyline here. I'll draw across the bottom there. I'll hit it. Oops. Let's try that one more time. There we go. Enter. It doesn't matter. If it's not even, you can trim the ends. It's no big deal. And so in this context, there's probably a little bit of space below my building before the floor. So maybe let's go up by a foot. That would be theoretically my floor level. And then let's go up from here. We'll go 8 feet. And that would represent the top or the ceiling level. And we'll go up one more time, and at least another foot for the ceiling, itself, the roof, whatever. And we'll draw that one across. And so I have these layers going across there, or excuse me, these lines like that. Take a little bit of time, and I'll do a trim to get rid of these lines that don't really matter. So I'll go ahead and type trim. My cutting object would be this object that runs across the top. And I can then get rid of these pieces there, and there. Okay? In reality, if we were looking at this as a true elevation, we wouldn't see this line or see this line because those are just hidden lines. But for my purposes here, I'm going to keep them. Okay? So now I need to draw my little windows. So I'll do the same strategy here. And I'll draw and pull down a few lines. So there. And there. And again, those are just polylines that I've pulled down. And I need to specify a line off the floor for the height of the sill of the window and a line for the head of the window. Okay, so let's say, and again, this is completely arbitrary. You can make it up. I don't really care. Let's go up here. I don't know. Let's go 3'6". And I'll draw across. And let's go up from here 6'8". And we'll draw across. And that gives us our nice little window opening. Okay, so I'm going to go ahead and trim off, again, using those two as my cutting lines. So we'll go to Edit, Trim, and we'll pick this and this as my cutting object. I'll go ahead and hit Enter, and I'll get rid of the lines at the bottom and the lines at the top. You know, the blue's a little hard for you to see. Let me change that color. I'm going to change it back to black in the hope that that's a little easier to see. Is that a little easier? I think so. Okay, so let's continue on. I want to draw this window again, and I'll do this as as practice. I'll repeat all the same things. Obviously, I could copy this window over, which would save myself a little time, but I'll go ahead and practice again. So I'll draw a line, polyline, straight down. I have snap to perpendicular turned on to make sure that it snaps perpendicular. I'll hit Enter to finish. I'll repeat polyline. I'll draw this down to where it snaps to perpendicular again. And then once again, I'm going to draw with the polyline. Everything's been polyline so far. And we'll go, using smart tracking, I'll go up 3'6". And I'll draw across, Enter. And I'll go, again, smart tracking, 6'8". And I'll draw that line there as well. I hit Enter to finish. And now I have these two horizontals, and we need to trim off the excess. So we'll once again go to Edit, Trim. Oops, sorry. Let me do Edit, Trim. And I'll select this and this as my cutting object. I'll hit Enter. And we'll get rid of those pieces there, there, and there. Okay? So all I've done, essentially, is I've established where the ground is, where my interior floor is, where each of these windows are, where my ceiling is, and where the top of my roof is. Now, if I had a sloped roof, obviously the elevation would look different. But for right now, we're not even really worried about the roof. We're just going to do walls today. So I have those two. I should probably draw the two windows that go over here as well. So for practice, we'll do it again. I'll go to Polyline. And I'm going to draw straight down to there. Polyline, I'll draw straight down to there. Enter. This time I'm going to use the head height the same, so we'll just go across. Now, we'll let it cross like that. And let's make the sill height a little bit lower since this is a bedroom window. Let's go 2 feet. Like that. We'll make it a bigger window. Okay? So previously I've been doing trims to get rid of these extra pieces. I could do trim as well, But if you remember from last class, there was a little cheater way of doing it, and it's to use a fillet instead. If I go to curve and then fillet curves or type fillet, as long as my radius is set as 0, I can actually just connect those two ends. So once again, if I go to fillet, and this is just, I'm showing you this because it's a way of speeding up your process. And so for some people, this will start to make sense. For other people, you'll just trim it off and it'll be fine. The more you work in Rhino, the faster you start to learn these little tricks that can help. So I have a fillet. I've set my radius to 0. And actually, by default, obviously on this computer, but on my own computer, generally my fillet is always set to 0 by default because I always leave it at 0. I rarely use an actual fillet. So it stays at 0. And it will let me go through and really quickly connect those corners together. Like that. So I'm right-clicking to repeat the last command. I click both sides of the corners and continue. So now I'm going to go ahead and select this curve here, or this window. And since I've already drawn it, I'll go ahead and just copy it. And I'll use this floor plan to copy from there to over to there to create a second copy of the window. So in reality, I probably would have done that all the way along and just made my copies because it makes life a little bit simpler. But it's good practice for you. So now that I have this kind of set up here, let me go ahead and I'm going to select the first window and I'm going to go to Edit and then Join, because I want this to be one joined continuous polyline. And you should notice when I do join, if I read the command line up here, it will say 4 curves joined into one closed curve. That's what we're after, is the one closed curve. And if we don't get one closed curve, maybe it joins into 2 open curves, it can be a sign that something's wrong. So let's do an example there. OK, so now I messed this up on purpose. Okay? But in this case, I have a curve that overlaps. I have a curve underneath here. And then I have these individual curves there and there. So if I were to select all of these, and I were to go to Edit and then Join, and I look here, 4 curves joined into one closed curve and one open curve. Right? So something's wrong here. Okay? And it probably means that I have one closed curve and I have an extra piece right there at the top. Okay? That's a problem. Okay? The other thing that could happen is, let me go back a second. Let me get rid of this, and let me draw a curve like that. Okay? Now if I were to join this, 4 curves joined into one open curve. Okay? Well, this one's kind of tricky, because if I click on it, it looks like a closed curve. But the truth is that there's a segment that goes over here, and then this segment goes underneath that. So there's an overlap happening right here. And that overlap will cause problems when you try to do an extrusion down the road. Okay? So we don't want that. So I'll type explode. There's my overlap piece. Let's get rid of that. And let's take this overall piece, join, 4 curves joined into one closed curve. That's exactly what we're after. So I'm going to do the same thing with this window. Edit, Join, 4 curves joined into one closed curve. Happy. Take these, Edit, Join. Obviously, I could type Join as well. And now those are joined. Okay, so let's say that I want to offset this to create a little bit of depth in this particular window. So let me go ahead and offset. My distance is not 1,200 inches. How about a distance of 1.5 inches, 1.5? And I want it to go to the inside, and now I get a little offset there. Starting to look a little more like a window. I'm going to repeat. Same thing. Edit, offset, curve, or excuse me, curve, offset, curve. There you go. Curve, offset, offset, curve. Obviously, I type in offset more often than not, but that's where it is. It's set, again, distance 1.5. We'll go to the inside there. I can right-click to repeat the last command. and we'll go ahead and put it inside there as well. So now I have little borders around each of my windows, right? Let's say that I wanted some window trim to go around the windows. I could repeat the offset again, and I could say that I want my distance to be 3.5. And we'll go from there, and that creates a little bit of trim outside the window. We'll do that as well. There. And there. So obviously I have a little bit of a problem because these are overlapping, and so that can be problematic. In reality, I should probably take these and explode them. Explode. Let's get rid of those lines. Let's get rid of these lines and that line. And then I'd redraw the trim that went around the window to include both pieces. Okay? That would allow me then to take these 4 segments and to go to Edit, Join, and join those together. Okay, again, you see that there's kind of a theme of I'm trying to join these together. You'll see in a little bit why the joining is important. Okay? Alternatively, right, we could change the windows. We could also just say, you know what, I really didn't want my windows to be that close together. Let's move that over, by 6 inches. Oh, that's so much better, right? And then let's take this window here and let's make it match. Move 6 inches there, right? So I could do that too. Again, there's no science to this. It depends on what you design-wise would want to have. Okay, so now I have a loose elevation of what I was after. And I haven't gone too in-depth with what the windows look like. I don't have mullions in the windows or any of that. We'll get to that. We'll build windows. We'll make mullions. We'll do chamfered edges. We'll get to all that. But we're just going simple for right now. Okay? So I have this elevation. And thus far, everything that we've done in this class has been 2-dimensional, except for the first day, but that doesn't really count. Okay? So last class, we did everything 2-dimensional. Now comes the moment where we start to make this stuff 3-dimensional. Okay? So I'm going to go from the top view. I'm going to double-click, and I'm going to go into the perspective view and make that big. So we can see as I right-click to orbit around that I have my floor plan and I have my elevation, but they're flat on the ground. And so the first thing that I need to do is I need to start to see this, instead of flat in the ground, in 3 dimensions. And this elevation, obviously, shouldn't be flat. It needs to be standing up vertically. So we're going to make that happen. And we're going to use a command called rotate 3D. And I think rotate 3D is awkward the first time you use it, and then it starts to make more sense. And that's because it's asking for more information than you're used to rotations asking. Okay? So we'll go up to transform, and you'll notice that there's 2 different rotates. There's regular rotate and there's rotate 3D. Because we're working in 3D, we're going to work with rotate 3D as the command. This, by the way, is written out under Rhino 5.6 if you want to look at the kind of the step-by-step of it. If we were doing that, let me see here real quick. Let me pull it up just so you can see. Let me log in real quick. All right. So this can help because you have the extra little image that kind of talks through what's happening. Okay? So if you want to look at that, you can of course look at that, but I'm going to go through it live. So when I go to transform and then rotate 3D, it's going to ask me first to select the objects to rotate. No surprise. What do you want to rotate? So I'll select all of my elevation, and I'll hit enter. Then it asks for the start of the rotation axis. So if we rotate in traditional sense, we have a point that we want to rotate around. Okay? The difference here is that instead of a point that we're rotating around, it's a line. And so we have to envision if I have something that's flat on the ground here, and I want to rotate this up so that it's standing up like that. The axis of rotation, or the line that I want to rotate, is this line right here, right? And I want to rotate around that line. Does that make sense? So the axis of rotation in this sense is going to be right here, starting right there, going over to right there. And the reason that I picked this is because this is floor level, and my floor plan would be at floor level. So I go from right there to right there. That was my axis of rotation, so start and end. Then it says angle or first reference point. So I want to establish a reference point, and that would be going along the side here as my reference point. And assuming that I have, oops, there we go. Oh, come on. My mouse is not clicking. There. Assuming that I have ortho turned on, which it is, right, I can control what this rotation is. If ortho's on, it will jump 90 degrees. So it's up in the vertical plane. So now, as we orbit around, you see that that is in the third dimension. Okay, so let's do that whole thing again. So I have it flat, and the first thing that I'm going to do is go to Transform, Rotate 3D. Select Objects to rotate. Go ahead and select those. Remember, I'm right-clicking to orbit. And you notice that when I right-click to orbit, it can be in the middle of another command. So I can always orbit as I'm working in Rhino. So I've selected the objects. Press Enter when done. Start of rotation axis will be right there. End of rotation axis will be right there. My angle or first reference point would be right there. And I want it to fold up to be 90 degrees. Obviously, I could have it go in one of the other directions if I wanted as well. So there it is, going up 90 degrees. And I'll go ahead and click. And so that gives me that first elevation. Make sense so far? OK. So at this point, I need to actually start making some real 3D surfaces. So I have this established. I have this established. But I'd like to go back to my layers and create a new layer for 3D model. Okay? Now I had a problem. I accidentally created the 3D model layer, and it showed up on the 2D drawing layer as a sublayer. Obviously, 3D model shouldn't be a sublayer of 2D drawing. So let's move that out. And there's actually a arrow facing left that says move up one parent. And if we click on that, it will move it outside of this 2D drawing layer. So now I have 3D model. I can create a sublayer for 3D model called walls. Notice that I have a walls layer here and a walls layer here. They're named the same thing, but they're underneath the 2D drawing layer and the 3D model layer. Okay, so it allows duplicate names as long as they're sublayers. OK, so let's make the walls layer current. There it is with the little X. And I should point out at this point that I can actually turn off all of the 2D drawings by turning off the 2D drawing layer. Or I can turn off individually just the walls or just the, why is my mouse so sticky? Sorry. Or just the elevation. There it is. So I have control. All the 2D drawings, just the walls, just the elevation. So with them still on, I'm going to go ahead and have walls as my active layer. And I'm going to take a look at the walls layer. And I want to make sure that these are closed polylines, okay, which they currently are. If they weren't, right, let me go ahead and explode it. And I had individual segments or parts of individual segments, I'd want to go through. I'm going to hold down Shift and select the lines that would make up a closed polyline. All right, so there I am. I'll type join or go to edit and then join. 10 curves joined into one closed curve. Perfect. That's what I want. Nice closed curve. Okay, this one happens to already be done as one closed curve. So I'm happy with those two pieces. So at this point, I'm actually going to make a 3D object for the first time. So we'll take the curve, and I'm going to extrude it. So we're going to go up to Surface, Extrude Curve Straight. You could also just type extrude. All right, so there it is. select curves to extrude. I'll pick the first curve there. I can select multiple curves, but I'm just going to do it once so that I repeat the process twice. So I'll press enter when I'm done. And then it asks me for an extrusion distance, which is good. But before I do that, I want to look at the options. Okay, so I have some options. First thing is I have a direction. I have both sides, yes or no. So just like an offset, I could have it going both directions at once. In this case, I don't want it to. Then I have something called solid. Do I want it to show up with a top and a bottom? Okay, in this case, I do want it to have a top and a bottom. So I'm going to say solid, yes. Okay. Then I have an option for delete input. Okay, sometimes you draw a curve on the ground and you extrude it and you want that original curve to go away because all you really wanted was the extrusion, the surface. You don't want the original curve. In this case, if you said delete input yes, it would get rid of the original curve. Since I have the 2D drawing on the walls layer, I can leave it there because I can turn the line off later on. I can turn the curve off later on. So we'll leave delete input as no. To boundary, if I had a boundary that was existing in space and I wanted it to extrude up to that boundary, I could do that. Right? Split at all tangents, we don't need to do that. And I don't need to set a base point for this. Right? So really the only thing I changed was solid should be yes. So it is. And then I can type in my extrusion distance. So that extrusion distance, right, is to the top of that wall. Because I have the elevation drawn, it makes life really easy because I can just snap to the top of the wall. Otherwise, I'd have to know that it was 9 feet, for example. Right? But I already have it drawn, so we'll just snap it to 9 feet. And now I have a 3D object. You may see this as a wireframe at first, which would look something like this, rather unimpressive. You will probably want to change it to be in shaded mode as your primary source. If you switch to rendered mode, which can be great for previewing V-Ray and whatever, you can end up losing objects like suns, lights, they don't appear. And that can be problematic down the road. So I suggest when you're doing modeling that you stick with shaded mode. And once again, to change modes, you go to the little triangle that's next to where it says perspective or whatever view you're currently in. And you click that triangle, and it's right here under wireframe, shaded, etc. Okay, so we're going to leave it as shaded mode for right now. And I have my first surface there. If this was not solid, I'd be able to see through the walls. I'm going to do an extrusion where it's not solid so you can see that for just a second. So let me take this, and I'm going to go ahead and extrude curve. And this time I'm going to set solid to no. Okay, and I'll extrude it to the same height there. And so now as we look into it, see how we can see down inside my walls? Makes it less desirable, okay? Because I'd ultimately have to put a cap on it if I wanted to. So in this case, I'm going to go back. We're going to extrude curve again. So that's under surface, extrude curve straight, or just type extrude curve. And I'm going to set solid to yes. And I'm going to make sure that the height matches up with my drawing or my existing object. There it is. Okay? So we have now some walls that are existing in 3D. That's exciting. That's what we're after. Okay? So now that I have those walls existing, it would be nice to have these windows appear on these walls. Okay? And you guys have, a lot of you have worked in SketchUp before, and you know that you can go get the component, you can try to stick it into the wall, and then you try to delete parts of the wall, and the wall disappears, and it's this giant hassle. Right? Yeah? Okay? So welcome to the magic of Rhino. So we have this drawing that's here, and we have these nice curves that we've drawn. And we've lined everything up, so it looks pretty good. The next piece of this puzzle, and this is part 5 in the exercise for today, is a command called project. And I would say this by itself is the best command in Rhino. Well, or make 2D. It's a tie between the two. Okay? We'll cover make 2D at the end of the semester. But for right now, this is the best command that you can possibly learn. And what it does is it takes a curve and it essentially throws that curve in a straight line and creates new curves on any surface that it intersects as it does it. Okay? Unfortunately, you have to be very precise with how you execute the command. So what we're going to do is we're going to take these windows right here and throw them off so that they end up on this surface. In order to do this, we're going to initiate the command in a view that is perpendicular to the direction that you want the projection to happen. So in this case, we're going to start the command in the front view. Right? So I can see my curve right there. Notice that when I select it in this view, we can also see it in the perspective view. I'm leaving all 4 views up so you can see this happen. Okay? So we're going to go up to curve from objects, project, or you can type project. All right? And when we do that, it says select curves and points to project. So we'll start with the first window, which is right there. And I'm going to select the window, the inside frame, and the outside frame. Once I've done that, I'll go ahead and hit enter. And then it'll ask me to select surfaces, polysurfaces, and meshes to project onto. Okay? Well, I have a nice polysurface right here. I'm going to go ahead and click on that polysurface. And you can see in the perspective view that it selects it for me. Okay? Now that I have that selected, I'll go ahead and hit enter, and you'll see it happen. So there it is here. It took those curves and basically threw them out in a straight line, and anywhere it intersected a surface, it made new curves. Okay? So this is really cool in a straight sense. We have a flat surface. I could, of course, take this and I could copy it and I could move it to be over there on the surface. Okay? That's fine. But imagine this was a curving wall, or it had a warp to it and it bulged out at us or something. I can still use project to throw the lines onto any surface that exists. So when we ultimately have a piece of topography, we have a floor plan, we could take that floor plan, we could project it down onto the topography. No matter what slope that is, we can get the footprint of our building to be able to cut it out. So it ends up being a very, very powerful command. That's why I teach it so early in class. So let's practice that again. You will have bad results if you try to do a project in a perspective view. So if I went to edit and then project, no, excuse me, curve from object, project, and it said select curves, and I selected my curves. We'll say it's that set right now. I hit enter. Yeah, okay, I want it to show up on this wall, and I hit enter. Okay, I get this. The projection missed the selected objects. Okay, it's because it's not in line. The view that I'm looking in is not perpendicular to how I want it to project. So I have to be in the front view to do this projection. Okay, so let's do it again. Curve from objects, project. I'm going to pick this second window here. There it is. I'll hit enter. Select surfaces or polysurfaces to project onto. There's my surface. I'll hit enter, and I get my second window right there. Now in that case, I have some extra lines that show up back here because it intersected this doorway a little bit. So I don't want those lines, so let's go ahead and get rid of those lines. And we'll press delete, and those lines go away. So I have it just here. I'll continue and do these two. I could also project all of these at once, so I don't have to do them as separate steps. I'm doing it as separate steps so that it's practice, right? And you're seeing it over and over again. So front view, curve from objects, project. My mouse is not clicking today. There we go. Select curves. There it is. I'll hit enter. Select surfaces. This time it is this half. And I'll go ahead, press enter. And now I get those windows on both pieces right there. Okay? So at this point, I've managed to get all of my windows onto my walls. I could very easily draw another elevation view for one of the other sides if I had windows in other places and do the same projection. Okay? For the most part, this has solved most of my windows. Okay? So now I'm going to go ahead and turn off all the 2D drawings because I don't need them anymore. Right? And now I have just the walls here. I guess theoretically I could have left these curves on one of the 2D drawing layers. Kind of doesn't really matter. It's an organizational thing. To me, they're part of the walls, so I left them on the walls layer. Anyway, so at this point, I want to actually cut out what's happening here. So I want to be able to cut out the window that goes through. And there's two different ways to go about it. One is a little bit more complicated than the other, though the one that's easier may or may not work depending on how well you drew your windows. Right? If you don't have a closed curve, the easier way will not work. Okay, so let me go ahead and show you. I'll show you the easy way first. So we're going to come down here, and there's an icon here that's called Boolean Union that has two spheres in it. We're going to click and look underneath that, and there'll be an object for make hole. Okay, it looks like kind of a little white line with kind of a window curve and a surface. That's what we're looking for. It's called make hole. You could also type make hole. It might be a little easier than finding the actual icon. Okay, and it says select planar closed curve. So we need to make sure that the curve is actually planar, which means it's all in one plane, which this curve, for example, is. Okay, so there's my planar closed curve. I'll press enter when I'm done. There it is. Now it says select a surface or polysurface. So I'm going to select my polysurface, which is right there. Then it's going to say, what is the depth that you want? So I want to be able to snap to the other side of the wall. So we'll snap right there to the other side of the wall. And when I do that, right, it will actually cut a hole straight through my wall, and it will give me these little surfaces on the inside, making it solid. Make sense? Okay, really easy. The key is you have to have that planar closed curve that's coplanar with the surface that you're punching through. Right? So it's very specific in terms of its requirements. So let's do that one more time with this window. So I'll go once again to make hole, which is underneath the double spheres right there. Select planar closed curve. There it is. I'll hit enter when I'm done. Select surface or polysurface. There's my wall. Depth point would be right to there. And again, I've cut all the way through. Okay? So if it doesn't work, we have challenges. So I'll do that with the challenge. Okay, over here, I'm going to do the same thing, but this time I'll use trim. We've already used trim before. We're going to use it again. I'll go to edit and then trim. I'll select that as my curve. I'll hit enter. Select object to trim. I'll select the surface. Okay, so I was able to create a hole in the surface. There, we can kind of see it. Now I need to go to the inside of the wall. And once again, I'll select this curve, trim, right there. And now I have a hole all the way through that represents that window. Unfortunately, it's still hollow. I don't have any jambs for the window. Right? So I need to put that together. And I'll do that by selecting enter to finish. I'll do that by selecting both curves that I did the trim from. Come on. Not this. By the way, if you accidentally select something that you didn't intend to do, if you switch from shift to control, you can deselect anything out of order. Okay? So I have those two selected, and I'll then go up to surface, loft. I don't need to worry about the seam. It's going to be fine. I'll hit enter, and I'll hit OK. And now I have essentially the same thing that the make hole did. I just had to do it manually. Obviously, way more steps involved in doing that, but at the same time, you can do it a little bit easier if for some reason the make hole isn't working. So once again, I'll repeat that. This time, I'm going to make my life a little easier and select both the inside and the outside at once. So there and there. I'll go ahead and type trim, and I will click twice this time to get both of those. Okay, come on. There we go. There we go. And so I get through. I'll press enter to finish the trim. Notice that the two objects stay selected, which means I can immediately go into loft and then enter one more time, and I create that inner piece. Okay? So that's one of the things about efficiency that you'll learn is the order in which you do commands and what things are selected can improve your speed as you start to model. Again, not really relevant at this point. So let me practice one more time. I'm going to take this curve right here. This time I'll use the make whole. Oops. Go to make whole. There we go. Select planar closed curves. There it is. I'll do these together. Why not? Okay. Go ahead and hit enter. Select a poly surface. There it is. My depth point would be right there. And I've now cut through both of those at the same time. Okay. So I have those windows cut. Same thing right here. This time I'll do the other method. I'll select both curves. There. Now we'll use trim. I'll just type trim. And then we'll click and click. I've got a hole through. I'll press enter to finish that. And then I can go up to surface, loft. One more enter. And now I have the inner part of the walls. Okay? So there's really two different ways of going about it. Either way is just fine. Okay? A couple more things that I want to try to do today, and then I'll turn you loose to practice. Remember, today is all about practice. So if you finish this easily, try to make a kitchen counter. Right? Try to do some of the other things that are in there and see how they turn out. Right? The more time you put in practicing now, the better and easier it'll be later on. Okay? So use the time that you have for practice. Okay? I want to show you putting in the tops of the doors really fast. So in this case, the way that we drew the doors left an opening floor to ceiling all the way through for the door. In reality, that wouldn't be the case. There would be a head across the door. And so I want to go ahead and put those in. So I'm going to go back. This time I'll just use the box corner to corner tool, which is right here. I'll use box corner to corner. It's going to ask me for the first corner of the base. I'll pick that right there as my first corner, right there. My other corner would be right there. If my mouse will click that point for me, thank you. And then I need to go down by a specific amount. Now I know that the height of the door should match up with the height of the window. That's how I designed it. So I'm just going to snap to that height right there. And I end up with a head across the top of the door. Okay? I'll do the same thing in the other places. So there's a box. We'll go ahead and go from here to there. And we'll control the height so that it matches up right there. And we'll do it one more time. There, to there, and to right. Oops. There. Okay, so I've filled in those little pieces. Now, these are separate pieces. And at first, you might worry that there's going to be a seam there when we do a rendering or something like that. There is a way of making the textures flow across these objects as if the seam wasn't there. So the fact that there's a seam long term isn't going to matter. Okay? So now that I've finished this, I'm going to create a screen capture of this to prove, obviously, that I worked on it today. So I would go to the little triangle, go to Capture, and then to File. And I would save this, and we'll put it into my folder for today, if I can find it. And yeah, this mouse is awful. I'm sorry. How many times can I click it? Can't win. All right, so then I can call this exercise 203, 203, and we'll say this is spring of 2017. And then I'll go ahead and save it, and then that will be what I post online. Yeah? Yes, everything's there. So if you got a little lost in the stuff that I was doing, obviously it takes me time to process this lecture. It should be up by the end of class today if I can make it work. But if you go to lectures, and if you go to spring of 2017, remember you're looking for 136, you would see there's lecture 203. Here's the previous lectures. You can pull up the fall's lecture, and there it is going through all the same stuff, essentially, that I did today. And there we go. You can hear me again. It might be under edit. Same process. Anyway, so it is there, so you can go back and see exactly what I did in the order that I did it in while you're waiting for the lecture to show up. Okay? So I know it's a lot to take in. Obviously, I'll float around and I'll help you guys get through these various things. The key part of this for today is to learn Rotate 3D and to be comfortable with Rotate 3D, and then to be comfortable with the project command. Those are the two things that I really want you to get out of today. All right? Okay, I'll turn you loose.